So, very good afternoon to all, respected speakers, respected audience. Just a small introduction. Myself, Ravi Sushant Chaudhary, and I am from Power Grid Corporation of India. I have 19 years of experience in transmission substation construction as well as asset management. Currently, I am working in a corporate asset management department in a digital initiative wing. So today, my focus will be absolutely on the practical application of AI in the field of power transmission and in a subset of asset management. So I hope it will be interactive, and I think most of the basic concepts of AI have been very diligently covered by my earlier speakers. So I'll not be focusing on that. So just what I'm going to cover in this small session, basically to see that where AI fits in our power system. I'll be discussing some of the use cases, and as everyone has talked about some challenges, definitely there are so many challenges in application of AI, and what will be the road ahead in our industry as far as AI is concerned. Everybody knows we are using AI in our daily life. I mean, it has become a very, very important part of our lives. Everybody knows about Alexa, and I think most of us are having, Alexa, and even in your smartphone itself, you have your face recognitions, as well as when you come to airport, you have Digi Yatra. So all these are the very, very key applications which AI is definitely. It is not going to be part of our daily life. It is already part of our daily life. So there are some basic things actually, as already explained in detail by, Professor Sir. But I will just brief you that there is a artificial intelligence, there is a machine learning, and there is a deep learning. So you have to see that where AI is the superset of all, and machine learning is the superset of deep learning. So there are weak AIs also, and we are also, as we go ahead, we are also going to have the strong AIs with multiple human capabilities. I will just share some of the few first AIs in 2024. Just आप लोगों को ये एहसास कराने के लिए कि AI बहुत आगे बढ़ चुका है और we have to catch with AI to be effectively using AI in our field. Iris is the first AI teacher. Qatar has already first AI hostess demonstration done. Kavya Mehra is the first AI mother influencer. We have the first anchor in India today. First AI anchor has already been launched. Devin is the first world software engineer, and first AI engineer in India is Devika. And in 2024, we had the first AI beauty pageant, which in India's Zara was represented in that. So we had recently Truecaller has launched its first AI scanner, and Aisha is the first AI employee. And our first anchor I have already discussed, that is there in India. So already, so much has already been done in this field. So what exactly, why we are going for AI ML? Is this the case that everyone in the world is going for talking about artificial intelligence, so we also start talking about artificial intelligence, or there is a really need of artificial intelligence in our field? The fact is that, just for an example of Power Grid, we started our company in 1993 when it was separated from NTPC. It was separated into three verticals: NTPC, NHPC, and Power Grid. Basically, we started with 25,000 of gross capital. Today, we are having a gross capital of 3 lakh crores, 25,000 crores to 3 lakh crores. So we have risen, grown up 12 times, and our assets have gone multifold. We are we are third largest transmission utility in the world, and we are the largest transmission utility in India. So we are talking about 282 extra high voltage substations, and line with 1507 lines, and approximately 2 lakh circuit kilometer of extra high voltage lines. So we have more than 5 lakh assets in place. So every asset in a second, if it has 10 data points. So you are ending up with 5 million data inputs in 1 second. I'm just giving a gross. So basically you have billion data inputs which are to be analyzed, to be understood, to come to a conclusion, and to affect your assets, to maintain your assets effectively. So definitely there is a huge volume of data. We are talking about 15 terabyte of data now, and in by 2032 we are going to have around 50 TB of data. So technology, definitely, if you are having such a, and just to add on that, when we had a 25,000 of gross capital, we had 8,000 employees. Today's we are having 3 lakh gross capital, which is going to be 4,50,000 crores by 2030, and we are still going to have only 8,000 employees. So we are not increasing. Our human capital resources are limited. Skill is also limited. So we have to leverage our resources from wherein we can use augmented reality and AI and other capabilities, data analytics to our system, wherein we can ensure that we are able to maintain our assets with the new regulations which are much more stringent as it was 10 years before. So this is what is the business case. Now, before you talk about AI, it looks very good, that beautiful picture comes when you just put something, a text in your chat GPT. But it is very important for companies like in a power sector, you need to have some basis covered before you talk about artificial intelligence and application of data analytics and also machine learning. You need to have digitalization and digital transformation. This is very important. If you are not having your basics covered, you will not be able to use your artificial intelligence in that way. So data and the quality of data is very important before we talk about artificial intelligence application in power sector. So this is what. So initially, just 10 years back, there have been a lot of digitalization works done in Power Grid. We had we developed a National Transmission Asset Center, which is a global icon, and just to tell you, there are more than 282 substations and 1,507 lines are being maintained by only four people sitting in a single room. So that has been done with the National Transmission Asset Management Center, wherein all the data is digital and it is available in a single screen. So we have given away with a lot of manpower requirement which was working in the shift for the operations. So Power Grid does not have any manpower dedicated for operations at its substation. All the substations are manless for operations. So by this we have saved huge savings on account of manpower deployment. So why we are going for this? Because I have already told you that we have already done a lot of digital transformation. So we have our basis covered. We have our data as a OT data, as a IT data. So OT data is coming from the operations, from National Transmission Asset Center, wherein all the million data points are being captured at every millisecond from all your sensors and all your breakers or all your equipments, and those are being analyzed in a historian. And after that is analyzed, it is being put in a data lake, wherein you are going to have your IT and OT data which is being merged. And after merging that data, you are going to have the analytics of complete data at every minute. So I will give you practical examples wherein we have implemented the IT and OT data integration and data analytics with the machine learning and AI capabilities. And I mean, it is so good that most of that setup has been created by our in-house engineers. So by this we keep on learning ourselves also, and we keep on training our software also. I've already discussed about this, that we are going to be a 50 TB data, by 2030-29, and our gross capital is going to further increase to 4,50,000 crores. So huge. Now, until as there is a necessity, we don't discover anything. अगर कहीं गर्मी है तभी AC है, अगर कहीं ठंड है तभी heater है. So everything comes with a necessity. So that is why these are the pain points for every utility, because these pain points are there. That is why we are searching for new options, that how we can strengthen our grid maintenance. So these are our focus areas, because since time is less, I am not going to go in theoretical aspects. I am directly going to cover the practical aspects which we have done in Power Grid. So PG Amrit, it is an image processing defect identification in transmission line, and this was awarded in a global platform. PowerGrid was awarded for that in 2023, 24. We implemented that in 2023, and let me tell you that since we have PowerGrid connects your first point at Leh and Ladakh and connects it to Kanyakumari. So there is and also I'm not talking about the international grids interconnections with other countries, that is also part of it. But since our asset base, it goes from very different geographical conditions. At Leh we are talking about -40 in Daras, and then we are talking about very high temperatures in the central region of India. So basically we need to develop a tool wherein we spend less time in fault detection and more time in fault rectification. So we have limited resources. So what we did is we developed a PG Amrit tool. I'm going to demonstrate that in my next slide. That we are going to capture that automatically by training it through machine learning, and that has been done by in-house capabilities. Initially, when we started off the things, we had the less sample size. The more we kept our software, we made it more samples, and it got trained. Just an example, everybody knows about Gary Kasparov. So Gary Kasparov, because this AI concept started from 1950. There were small concepts which were there, and they were Deep Blue and all that. IBM, he played a chess game with the IBM software in AI, and he won in 1989. Later on, that software got trained, and in 1996, I think he lost, and he was not able to believe that he has lost, and he was, totally, bamboozled with that. So it happens because your system gets trained. You have to be patient with the AI application. And let me tell you, whenever you are taking a digital initiative in a PSU or in a company with a large asset intensive base, it is very important that you have to take so many initiatives. You have to be patient with the initiatives. You have to keep them, make them, train them these initiatives, and then ultimately the results will come. It is not a game of one night. So then reliability centered maintenance. This is we have a tool called PALMS, that's PowerGrid Asset Management, Asset Life Health Management tool, wherein with the help of your IT and OT data integration on daily basis, we have an algorithm inbuilt. So after, just like for a circuit breaker, we have all the data, OT data, like its operation time and everything, and then we have the IT data of its testing, like DCRM and everything. So the complete DCRM curves, I'll give that example in that those are analyzed with the help of AI only. No human intervention is there. All the SFRA signals, which otherwise engineers used to take a day to study the complete signal, whether it is matching with your pre-commissioning signal or not. So what are the changes? Is there a winding shift or not? Nothing is. Today we are not doing anything, with human intervention. Even our test results, some of the test results we have done that directly from the kit itself. It directly goes to your software ERP. So there is no human intervention. There is no chance of human error. So let me tell you, artificial intelligence is not, as far as I'm not an IT engineer, neither I am an expert of artificial intelligence. But what I can understand from a concept is that it is not going to, what you call as replace human intelligence. It is going to augment human intelligence if it is used judicially. So we have to see that how we are using. Then automated analysis of test results. We are having an asset performance manager, which is a huge software which is totally based on IT and OT integration. And with a single click, you can click any asset and you can calculate its health index, its criticality index, and all the features in a single click. End of life, then cost. How much you are going to spend in asset management of that asset. So that is APM, asset performance management. Then we have a satellite-based vegetation management, wherein we are working with the ISRO, and we are going to finalize that very soon. Then we have a substation inspection process through different methods. One is I2P. There is a tablet concept wherein we scan. All our equipments in the switchyard are having a QR code. So you can scan the QR code and you can get the complete history data of its test results. So when you are feeding the test results, so you can simply check what is the trend. So you need not to go to ERP and SAP to check the data, and then you have to validate, and all things are gone. So single click, you are able to scan the QR code, you have to feed the data, and we are also planning to put a reality, picture recognition in that, wherein OTI and other picture data can be captured directly. So then we are also having a, and let me tell you, for substation inspection, we are having a robot. So we have already tested that, and with the help of IIT Kanpur, there was a collaboration between PowerGrid and IIT Kanpur. So we have developed a in-house indigenous substation robot, which is going to inspect the complete equipment through artificial intelligence only. Then we have IoT. We have started application of IoT in our substation monitoring. We are having number of the sensors wherein we are going to send that data wirelessly directly to our algorithms, AIML, and that data will be clubbed with our asset health to give the real picture. Then, as somebody told, HRD, we are already having the virtual reality modules. So young engineers which come to PowerGrid, they have to get trained very, very fast, because the asset base is growing. With the solar integration, it is going at a very rapid pace. So you have to ensure that engineers which used to take 5 years to be independent and operate the substation or maintain the substation or construct the substation, they need to be ready in a 1 year. So we are having a virtual reality in our leadership academy at Manesar. I will request everyone of you to come and visit Manesar. It's so many global utilities come and they visit and they get trained. So basically it's a complete augmented reality. So wherein you can see each and every part inside the transformer or inside the GIS. You can visualize and you can understand with the 3D glasses. So it is very easy for engineers to get equipped with the system and they can understand. Because otherwise you take years and years when transformer will be open, तब आप उसके अंदर देख पाओगे कि क्या हुआ है. हो सकता है आपको वो मौका 15 साल बाद मिले, कई बार होता है, मिलता ही नहीं है. So that is very important that you should be able to at least have some kind of knowledge. Then we will be talking about certification awards and accolades. Because until and unless you are rewarded, nobody is going to recognize you. So this is how we are using machine learning. I think the picture is not very clear, but the thing is that we have, with the help of our knowledge, we have captured different defects. What can be a possible defects in a transmission line? So what we have done is that through machine learning, we have, defined those defects. And it just does not happen that you take one picture and you simply, identify the defect and, it will give you the thing is that for increasing the accuracy, you need to have a large sample size. And that too with different backgrounds, that too with different angles, and also with different situations. So that has been done, and we are very proudly we are able to say that now we have reduced our manual patrolling by more than 60%. So we firstly capture the images through drones as well as through, because when you are capturing from the drone, you are capturing from the top, and when you are capturing from the bottom, the sky is the background, and when you are capturing from the drone, your background is your soil, earth, mountain, something like that. So that is why you have to train your system. Otherwise, it will for a okay image, it can also tell you that this is faulty. So we have covered more than these kind of defects. I think more than 47 defects. Now we have gone to 96 defects. So these are insulator damage. So otherwise we used to take a lot of time. We need to have shutdown to go to the tower top and to see the defects, and then ultimately again take the shutdown to come and nowadays we are talking about PowerGrid has the largest availability. We are talking about availability of more than 99.8. So it is a challenge that we have to ensure that we do it with the artificial intelligence. So all vegetation, everything is being if your insulators are contaminated by the bird excreta or not, so everything is covered. So it is like this, and immediate your notifications are being created in your ERP system, and they are reflected, because ERP is not so user friendly. So what happens is that we create, the data goes in the ERP and it comes in your PG Darpan dashboard. So notification is created to the concerned engineer with the defects. So then after that, those defects are, he concentrates on rectification of defects rather than identification of the defects. So these are, even your angle is bent, your bolt is missing. So all those small things have been trained in a machine learning, and it took us more than 4 to 5 years to train each and every defect. And ultimately, initially there was a lot of, I am again saying that it is not, AI is not a technology which is very easy to use, because suddenly you will say that iska accuracy bahut kharab hai. but ultimately you have to work hard to ensure that accuracy is improved. So this is how it goes to the process engine. It is processed very fast, and after that you are getting the, for example, you can see here how it is being, your pronar ring is reverse, so you have to train that it is on the reverse side. So this is how you so I am talking about only the practical cases. There can be so many things which can be done with the AI, but we are talking about here the practical cases. Here the grading ring reverse, what is the accuracy of that? So we have to compare with the practical aspects. कितना मैच कर रहा है, अगर वो नहीं मैच कर रहा है, we have to train for it. There is no other solution. So this is the concept how it goes to your system. So it is totally paperless. For maintenance we don't use any paper. So again, for reliability centered maintenance, which is another application of monitoring your real time health and criticality of your assets. So we have implemented, so these are different form of asset maintenance. You can have a run to failure, and you have a value optimization and reliability centered. Currently we have done reliability centered maintenance for our major assets like transmission line, like circuit breakers, as well as transformers and reactors. And recently we have been awarded by SGUF for reliability centered maintenance patent for transformers. So in a reliability centered maintenance, what we have done is that we have captured two axes. So I will just, because the time is less, I will just go to the concept. So basically you have, earlier you used to have only the health score. So BARMS is our software which calculates the health score real time with integration of IT and OT data. And in that integration, there are many things which are done with the help of AI/ML, like my DCRM signature. So my DCRM signature, my travel and my stroke length, when my breaker closes and it opens, and it closes and then opens. So in a DCRM signature, it follows certain path. So what it does is that we have the complete set data which is filled in that algorithm. So if that violates any limit in any in 1 millisecond or in that time frame, so that your health becomes critical. So probability of failure is 1 minus your health. So the more is your health, less is the probability of failure. Another is the impact score, because impact score is very important in reliability centered maintenance. The concept is that, for example, a breaker which is connecting a NER feeder or a radial feeder in a NER or a radial feeder in a Leh and Ladakh is more important than you for a breaker which is connected in a multi bus system. So basically, in case of, also in NCR where parliament feeder is there, when state cities are there, secretariat is there, so you have to add your impact score there. So more the impact, you have to maintain your breakers accordingly or your assets accordingly. In addition to that, your tariff. For example, a 765 kV breaker in a some system is having more tariff loss. So you calculate tariff loss for each asset and you map them in the impact score. So this is real time. So the moment your health improves, it goes to the green zone. So this is how reliability centered is. These are the benefits of reliability centered maintenance. We hardly we have ensured and we have checked our results that more than 40% of savings we have done. And from the availability of transformers and transmission line of 99.8, we have gone to 99.89 in 1 year. And I am not boasting upon the results because this is a learning process. Next year it may come down or it may improve. It depends upon how sensibly we optimize things. So this is the concept of Power Grid health management. So this is the model. So how we calculate. So there is a AI and ML in that, which all your signatures and all your test results are evaluated directly by the system itself. So you need not to have any human intervention and human error in that. So the scope of human error is reduced. So then we are having this signature I am talking about. This is a SFRA signature of a transformer, which is being directly evaluated by or checked by the AI ML. So there is no human intervention in that. So we also have the safety assessment. We have the intrusions, because in a power grid what happens is that when you are maintaining, you have to ensure that there is no unwarranted intrusion in the system. So you can tag every part of your maintenance area and then you can monitor it from the local dashboard at your system. So with this we are able to supervise more stations in a more effective manner, in a with less manpower. In addition to that, we have a vegetation management. It is more prominent in NER because there the growth of trees is very fast, and we have more 132 kV lines in NER. Otherwise, our lines are mostly 400 kV and 765 kV and even 1200 kV. But basically, for lower lines, the distance between your earth and the conductor is less. So in case of any steep growth of vegetation, you are going to lose. There will be a fault in your line, and you are going to lose on availability. So you need to have a smart vegetation system, which not only calculates the height of the tree or the vegetation, but it also augments it with the future forecast in 1 year. So you have to see that what time you have to get the shutdown and get the trees cut. So this is done with the satellite imaging, and we are doing it with the help of ISRO. So this is the concept. And intelligent inspection system I already discussed. So all this data is, you have a QR code here. So complete data is being just with a single scan of your tab. All our engineers in a substation are having a tab. So they just scan the QR code and they get the complete data history, all 10 delta results or SFRA results, everything is there. So they can simply see the increasing trend here only. So they don't have to go to their systems and put the data manually in ERP and then wait for the evaluation to happen and then act. So they can act if there is any absurd change or plus minus 10% change is there in the system. So this is, all these cases are not something which is, I'm talking about future. This is already being implemented, and this is, I'm talking about the substation inspection robot, which has been designed and implemented with the help of IIT Kanpur and PowerGrid. So this is having all the sensors inbuilt to thermography and for collecting all the readings and everything. So this is being this is going to be showcased in GridCon 2025. PowerGrid is going to have a international conference with more than 2,000 delegates at Yashobhumi from 9 to 11 March. I will request everybody from you to kindly come and join. It is the biggest international event in power sector in India. So there will be conferences and all the delegates are coming from abroad, and also we are going to have the exhibitions of all different transmission assets. So therein you can see the live demonstration of your substation robot. So we are keeping space. So all these kind of data, and you can see the accuracy also. So we are not talking about perfection yet. We are talking about intelligence. Yes. So we will be keep on learning, and will be ensuring that this error goes further down with the help of technology. So we have the valve hall robots in our HVDC substations, which monitor all the key parameters in a HVDC valve hall. So this has been not done with any collaboration. This has been discovered by PowerGrid and implemented by PowerGrid engineers only. So this is also being showcased in GridCon 2025. This is in-house robot. This is having less height because it has to move in the room. So it is programmed to do all the inspection itself. 3D printing also, since in COVID we were not getting the parts of some of the key products. So with the help of modeling, we have been able to get some of your PRD, pressure release devices for transformers, as well as your valve cooling pipes. These were indigenous developed with the help of 3D scanners by PowerGrid, and ultimately it saved a lot of money and dependency on OEM. And IoT I have already discussed, so I will not take much of time in that. So in IoT there is a practical application in one of our stations in NCR where a lot of load is there, and in summers this time we saw a 15% rise in the load flow in the system due to high demand. So at that time the temperature rise are very high in the connectors, in the terminal equipments, in the isolators especially, where the contacts are not so very good. So basically what it does is that there is a camera which is inbuilt in the tower. So this camera senses your rate of rise of your temperature. So it analyzes the rate of rise of temperature, and if it goes beyond that, it creates alarm. So more than 45 hotspots during that time in one day, we have been able to get it done without any loss of availability. So that was only because of improvisation of technology and IoT sensors. So this is what our APM is. So it is just about, it is not something very what you call as most of the utilities in world, they have already gone for APM, but it is very important that your data authenticity is very important. It is a model, it is an algorithm, it is going to predict your asset health and your risk, everything, but until unless your input data is correct, you are not going to get the good results, even how much you invest. So this is going to be implemented. I think this I have already discussed this part. APM also. This is our digital tree. So these all verticals are going to be combined in a single screen in asset performance management. So we don't want our engineers to go to different IT application for a different health model. So we want our engineers to concentrate on their requirements rather than fetching the data. So this is something which is we have felt that we have lost so many man hours of our engineers for getting the data. So the data is going to be will be there in a single click, and all the risk mapping and your asset health will be mapped in a single screen for every asset. So if you clicking a transformer at a daily, I mean, with a single click you can get the end of life and everything in a single click. So this is we are implementing, and I mean our target is by 2025 we are going to implement this in our system. And in internet there is a benchmarking of global transmission utilities, which is called as ITEMS, International Transmission Operation Management Study. And let me tell you, Power Grid was positioned as first in international among all the top global utilities in the world in ITOM study. So it is very important that until unless we learn and upgrade ourselves, and we don't have any option to not to use AI. We have to ensure that we use AI in a way that it is helpful to us. Now this is impact of different utilities with the application of. And what is our plan? Actually, this is something which I will go fast. This is something which you visualize after 5 years where Power Grid will be. So we want to have a digital control room wherein if there is any fault, our robot will be triggered. He will go to that area. This will be a manless substation, and he will be able to capture all the parameters. The relay parameters and everything will be there in the screen itself, and it will go to the control room. It will see all the critical parameters are checked, and then all the asset investment plan, the real-time data of the cost, replacement, refurbishment will be on the dashboard of the top management. So they can simply, 4 people sitting can control the complete system, and they can see what they can do in this outage. So every data will be available so that they can plan judicially. So this is what we are envisaging that Power Grid will be doing after next 5 years. We want ourselves to be the pioneer in digital transformation as far as the transmission sector is concerned, and we are committed to do that. Our management is committed to do that, and without management commitment and without management support, it is not possible, because it takes huge determination and huge investment to basically go through all this. These are the digital models. I think someone of us was talking about the BIM models and the digital model. We are going to have the digital twins for all our equipments. We are going for transformer and transmission lines first, because we have to go gradually, and then we have to make that models available for all the other asset classes. So with this, I think I am going to. There is one more aspect I am going to cover. Another 2-3 minutes I am going to take. So these are some of the areas which we are going to target in next 2-3 years. So what we are doing, this is our path. We have a roadmap, very strict. Our management is committed to have a digital revolution in Power Grid, and we want to be one of the best among the global utilities. So our competition is with us. So we have to ensure that we keep on improving on the daily basis. So these are the technologies, and let me tell you, every technology is not successful. Every AI application is not successful. We have to go through those applications, we have to learn, we have to do the change management, and if we found that it is not good, we have to rethink about that, and some of the cases are also dropped. So every case is not, every technology may fit in UK, may not fit in India. So we have to see our context, we have to see our manpower cost, we have to see our scenario, we have to see our grid parameters, because our grid, we are talking about 30% renewable energy integration today, and we will be talking about 60 to 70% renewable energy integration by 2029. So we have to see that we are having a system where there is no inertia. So protection is a challenge. So we need to have synchronous condensers. So every challenge is different. So that is why this is our plan. So what is our expected? These are the what digital team, what we have done is We have also created a framework for management that these kind of savings are expected in next few years with the implementation of these things. These are our, and let me tell you what the good work has been done by our predecessors by the implementation of NTMC and ERP. If that was not done in 2010s, we would not have been in a position to utilize artificial energy in our system. So it is all about the good work which is done 10 years before. We are able to have a good data and we are able to use data in our system. So let me tell you further, just to let you know that we have been ISO 55001 certified in asset management, and we are the largest utility in the world to be certified in asset management. And we are 7th in India, and first one is T3 Airport, Delhi. So in electrical utility, we are the first one to be certified for ISO 55001. And initially, we were offered a consultancy of 23 crores in 2 years time by a foreign consultant, but we did it complete in-house. We did the complete digitization. For our asset management, we made a chatbot, and chatbot is made from a complete digitization. All our IM circulars, knowledge books, everything is digitized. You can simply go to the portal, you can simply search 10 delta, and you can get each and every data from that 10 delta in a fraction of a second. So there is no hard copy of papers which is required to be kept, and because we have found in our earlier learnings that when people go, the knowledge also go. And papers are next person is not able to find out the papers. That happened with me also. So I mean we have to ensure that we have the complete digitalization, and our power is the digital data. So that is nowadays your asset is not only the physical assets like breakers and transformers. Your asset is your digital data and your analytics. So the more you are able to have that data and learning, if you're losing that learning, I mean it's a big loss. We were able to implement Amrit because we had all the photographs of all the different areas, including from the coastal area to the Himalayas at Ladakh. So that is why we were able to develop a model which is more than 80% successful. Otherwise, it was not supposed to be. We have a strong commitment in asset management policy to have a digital transformation from the management. So we are committed to do that, and that is our strong driving force. That is why we are here, and we are committed to. And there are key challenges. Let me tell you, in a AI application, as sir has already told, I will not be stressing upon that. The quality of data is very, very important. The moment you are not sanitizing your data and you are just going for AI will bring heavens to your system, that will never happen. Unless you sit in the desk and validate your data and get it prudent, then only you will be any kind of concept will work. Otherwise, it will not work. Data analytics, you need to have a huge data analytics. You are talking about 5 billion points analyzing in a minute or in a 2 minute. So you're talking about huge data point. So you need to have big data centers. We are already planned, Organized has already planned a big data center, big cloud at NTMC Manesar. So that will be subletted to other companies also, but it is for in-house application also. You have to see the cost implications. The initial cost implications are very, very high. You have to ensure your engineers are getting trained by the virtual reality, right? You have to data centers. And these are the awards, few awards I have just kept. Recently we were awarded by Golden Peacock Award, and then for ISO 55001 certification and global recognition in asset management for liability center of transformer reactors and transmission lines. And also we were able to establish the reduction of cost in that. So thank you very much. Thank you for bearing with me that I have taken a slightly more time. Just a small video before I close, because I just wanted you to see this. This is a good one being created by Organized only. So this one is a reality. We have created a headgear system, augmented reality, wherein because we have few experts, we don't claim that we have all the people are experts. So basically, what happens is that we have an expert sitting at one system. Those experts can easily guide a person who's working inside a asset or in a control panel. So I mean, with this, the errors have gone down. So this is an expert who's sitting. He is able to see the real picture. What exactly the person who is at the 1000 kilometers away at site. So no need to go for physical. You can. If there is something very drastic has happened, you need to go to site, but most of the things you can resolve, 80% of the things you can resolve at sitting at your control room. So experts can guide which wire you need to touch, which system you need to touch, and this has been implemented 1.5 years back. So so this is something which has already been done. So with his headgear, the person sitting at the control, I mean at the corporate center, or somebody at the expert sitting at the regional level, he is able to, I mean, simply guide him and get it done. So these are some of the aspects of practical examples of artificial intelligence application in Power Grid. Thank you.